Question 6. Now we start off with our acceleration is given in the question in terms of I and j, and we need to find the velocity. So the way we get the velocity from acceleration is we need to integrate. So v is going to equal, and we're integrating with respect to t. So this one is going to be 5t squared over 2i minus 15t. Now we're adding 1 to the power, so that's going to be to the power of 3 over 2j. But then we have to divide by the new power. So dividing by 3 over 2 is the same as multiplying by 2/3. And then don't forget our constant of integration plus c. So let's tidy this up to start. So v is going to equal 5 over 2 t squared I minus 2/3 of 15 is 10, so that's minus 10 t to the 3 over 2j plus c. Now, like you're doing pure maths, the next thing you've got to do is you've got to find a constant of integration, and we can find that by substituting t equals 0 for when we've got 20i. So if I put 20i equals, when t equals 0, that term's going to be 0. When t equals 0, that term is going to be 0. So we've just got a plus c there. So our constant of integration, c, is just going to be 20i. So if we put that back into our v equation, we're going to get v equals 5 over 2 t squared I minus 10t to the power of 3 over 2j plus c, which is our 20i. Now, what we're aiming to find in the end is the speed of p when t equals 4. That's from the question. So first of all, we need to find v in terms of I and j. So we're going to sub t equals 4 into the above. So we're going to get v equals, now t equals 4, so that's 4 squared. That's going to be 16. 16 divided by 2 is 8, so that's going to be 40i minus, now if t is 4 in this one here, square root of 4 is 2. 2 cubed is 8, so that's going to be minus 80j plus 20i. So then let's collect it into I and j components here. So we've got 40i plus 20i is going to be 60i minus 80j. Now the question asks us to get a speed for this here, so what we have to do is to transform this to get the magnitude. So imagine you've got your I and your j components. That would be your j in the upwards direction, and horizontal would be your I. We want 60i, so imagine starting here, 60i, we go 60 to the right, so that's our 60 component, and then our j component minus 80, so down 80. So that's going down 80 there, and then what we'd want to do is we want to find out the shortest route for that there, that's our magnitude. So looking at this here, the speed is going to be, it's a Pythagoras, it's going to be 60 squared plus 80 squared. And if you do that on your calculator, you should get that to be 100 meters per second.